So today we're going to be looking at the 2024 HSC Maths Advanced paper. Specifically today, we're going to take a look through the multiple choice questions. So for question 1, the question asks, which of the following could be the equation of this function? What we see is that the equation of the line is y equals mx plus b, where m describes your gradient and b describes the y-intercept. And what we see is that our 4 options have this choice. So what we need to then consider is that the gradient for all of these are either positive 2 or negative 2. Okay? And as we should observe, as the line moving from left to right is going downwards, that means we have a negative gradient, so we're going to only be considering C and D. What we also see is that the y-intercept intersects at a positive number. Okay, we don't exactly know what this number is just by observing the graph itself, but we can reasonably assume, based off the information in the options, that this is positive 3, and as a result, our answer is C. So the next question says, in a group of 60 students, 38 play basketball, 35 play hockey, and 5 do not play either basketball or hockey. How many students play both basketball and hockey? So what we observe is that there are 60 students in total, and we know that 5 don't play either basketball or hockey. So if we subtract that from the total, we get 55, and that essentially means that there are 55 students who play either sport. We don't know how many play both exactly. However, we know that amongst the two, there are 55 total students. So what we then say is, well, we know 38 play basketball, and we know that 35 play hockey. So if we add that together, we get 73. So that includes students that are sort of doubling up and playing both sports. So out of the 73 that we have, 55 of them, out of the 73 spots that are available for sport, like sports that are being played and people that sign up for the sport, that's shared amongst 55 students. So all we do is subtract those two numbers, and we arrive at our answer, which is 18, and that corresponds to B. Question number 3 says, peers' marks in Year 10 assessments are shown. The scores for each subject were normally distributed. In which subject did peer perform the best in comparison with the rest of Year 10? So what we see here is we need to decide for which of the exams peer did best in, and that isn't just determined by the mark alone. So if we were just determining it by the mark alone, history would be the answer, but that's not the case because we actually don't care about the raw mark. What we compare is how it was best in comparison with the rest of Year 10. And so what we need to do now is compare it in terms of standard deviations. Okay, so we are looking at z-scores, and we should know that the z-score is equal to x, which is the mark, minus x bar, which is the mean, over the standard deviation. So for English, this is equal to 78 minus 66 over 6, which is equal to 12 over 6, which is equal to 2. For maths, we can see that it's 80 minus 71 over 10, which is 9 over 10, which is 0.9. Science, we see it's equal to 77 minus 70 over 15, which is equal to 7 over 15. We don't really need to know what that number is. All we need to know is that that is less than 2, which is our largest standard deviation of the bunch so far. And then we have 85 minus 72 over 9, which gets 13 over 9, which yet again, isn't larger than 2. So that means English, which had the highest standard deviation, is the subject that Pia performed best in comparison to the rest of Year 10. What we have here is the parabola, and they give you the equation, is reflected about the y-axis. This is then reflected about the x-axis. What is the equation of the resulting parabola? What we see is that this is in the form y equals x minus b squared minus h. And this is a parabola that has a vertex with coordinates bh. So if we just draw a graph, the vertex is going to be at 3, 2. Okay, so 3, 2. So that is going to roughly be here, where the x coordinate is 3, the y coordinate is 2, and our parabola looks something like this. So when we reflect it about the y-axis, we then get something here, where our vertex is at -3, and the y coordinate remains the same, so it will look something like this. And then when it's finally reflected about the x-axis, we end up with something like this. And so we have a vertex at -3, -2. And so when we then consider what the coordinates of the graph are going to be, we understand that because it's in this form that we identified here, because it's in that form, the inner bracket is going to have a +3, so it's either C or D. And what we have is a negative out the front because this is concave down. Okay, this is a concave down parabola, so there needs to be a negative at the front. The reason why this +2 is not a -2, because we have a -2 as the y coordinate of the vertex, is because there is that negative out the front. Because the whole graph is flipped down, technically if we were to sort of like expand the bracket here, this +2 would sort of go away, and in that regard, we still keep it as a +2 because we've sort of factored out the relevant negative, and the answer is C. Question 5. What is the integration of 6x plus 1 all to the power of 3? So this is a pretty simple integration. What we need to do is we need to recognize that the integration of the function of x raised to a power n is equal to the function of x to the power of n plus 1 over the derivative of that function multiplied by n plus 1. So when we have the integral of 6x plus 1 all to the power of 3, this is equal to 6x plus 1 all to the power of 4 over 4 multiplied by the integral of what's inside, which is just 6. And so that means we get 1 over 24, 6x plus 1 to the power of 4. Obviously, there is a constant involved, so we have the plus c. So our answer is A. Question 6 says, what is the domain of this function? So what we need to identify is that this function, the domain is going to be restricted by the fact that it's on the denominator and also restricted by the fact that it's in the square root. So because it's in the denominator, we have x squared minus 1 not equal to 0. But on top of that, because it's in the square root, this whole x squared minus 1 that I've identified here can't be less than 0. So it needs to be greater than 0, and it's not greater than or equal to 0 because it can't be 0 because it's on the denominator. So it's just strictly greater than 0. In order to solve this equation, we factorize, and we can use the difference of two squares. And we can then just sort of draw a parabola, and we can see here that this is a parabola that has x-intercepts at 1 and positive 1. And we can see that the graph is greater than 0 when x is less than -1 and x is greater than positive 1. So the graph used to describe the range that's used to describe this is D, and it's not B because this includes the square bracket around the ones, and as we identified before, because our range, the x is not on the, because the x is on the denominator, it can't be equal to 0. And because it can't be equal to 0, it doesn't satisfy an equation that's greater than or equal to 0, and that's why we don't include the 1. Cool. The diagram shows the graph y equals f of x. Which of the following best represents the graph y equals function of 2x minus 1? So what we see here is, so we have a graph and we need to figure out how this function has been translated. And what we need to recognize is that by applying a factor of 2 here inside the function, this creates a dilation, okay? And because it's a 2, what you should imagine is that it squeezes the function inward, and we're going to have something that looks a lot tighter. When we have this -1 here, this is a translation from the x-axis, and a -1 essentially means here that we're shifting it to the right. Okay, so we're shifting it to the right in the positive direction. So what we need to do first is we need to shift it right by 1. I like shifting it right by 1. So if we shift it right by 1, what we get is something like this. Okay, so it looks the exact same. It's not squeezed, it's not elongated in any way, it's just shifted to the right by 1. And then when we take this dilation of 2, we are squeezing it by a factor of 2. Okay, so we're sort of dilating it by a half, which basically means that the x coordinates all get halved. Okay, so I'm going to do this in red. This 1 goes to a half because half of 1 is half. This 3, this other x-intercept, goes to 1.5, so it goes here. That's because half of 3 is 1.5. This other x-intercept over here, this is 5, and this is basically going to be equal to 2.5 because half of 5 is 2.5. And so if we just sort of follow the graph in that way, and we preserve the y values, we end up getting our graph. And if we kind of scroll down, what we see is that this is equal to C. I'll just change the color. It's equal to C. Okay, we can see the x-intercepts at half, 1.5, 2.5. The y coordinates seem to stay the same, and yeah, it's exactly like the red equation that we have up there. Question 8 says some data are used to create a box plot shown. A histogram is created from the same set of data. Which of these histograms is not possible for the given box plot? So this is a bit of a tedious question. And the reason for this, I don't think it's a very well-designed question, and the reason for this is just because it requires a lot of manual steps, and yeah, doesn't really demand much critical thinking. So how do you actually solve this question? What you need to recognize is that the median here is directly in the middle of this box plot. Okay, so that just means that the median is in the middle of the data, okay, or your Q2, as I like to refer to it. Your Q1, which is your lower quartile, is over there, represented by this line, and Q3, known as your upper quartile, is this line. This end here, that represents your max. This end here, this represents your min. And what we need to sort of observe is that yes, the Q2 is in the middle, but we need to also observe that the distance between Q1 and Q2 essentially is half the distance between the minimum number and Q1. That's the main thing that we need to identify. Once we get that, we need to then work with our data. And this is where it gets really tedious because it requires you to essentially just list out examples of the data. And yeah, just list out what the data actually is. What we need to observe is that each plot has 16 scores, right? And what I mean by that is if we count, so this axis here, that's representing frequency, and this axis here, even though it's not labeled, it represents your score, okay? So here we've got not a score of 2, but a frequency of 2. Here we've got a 3, a 2, 2, 2, 3, 2. If you add all of these up, you get 16, okay? If you add all of them up, you get 16. So because there's 16 scores in all of these, I'm just going to rub all this out. Because there's 16 different scores in all of these, the Q1, Q2, Q3 are all going to be relative to the same position of the scores. And what I mean by this is, well, if we have essentially 1 through to 16 as the different scores, okay, all the way to 16, the median, okay, the median would be between the 8th and the 9th score if we were to divide it by 2, okay? That sort of score there would split the data in half. That also then means Q1 would be between 4 and 5, and Q3 would be between the 12th and 13th score. Okay, so let me sort of just write that down. So obviously the minimum number, is the first score. The Q1 will be between the 4th and 5th. Q2 will be between the 8th and the 9th. Q3 will be between the 12th and the 13th. And the max will obviously be the 16th score. So when we try and work out this, where the difference between Q1 and the minimum is half that of the distance or the difference between Q2 and Q1, essentially we just work out those differences for all of them. So essentially we can ignore this part and just focus on these 3 numbers here. So for A, we know that the minimum is equal to, well, actually, we don't know what the scores are, but let's hypothesize here and let's just assume that the scores were 0, 1, 2, 3, 4, 5, and 6. 0, 1, 2, 3, 4, 5, 6. And it followed that for all of them. Okay. Well, our first score, right, our min equals 0. Q1 which is our fourth and fifth score. So we have 2 here, and then we have 3, 4, and 5, all at a score of 1. So if we take the number which is between our fourth and fifth score, they're both between 1, so our Q1 is equal to 1. What about our Q2? Our Q2 is between our 8th and 9th score. So the 8th score, so we're at our 5th score here. Our 8th score, our 6th score is there, 7th there, 8th there, 9th there. So between 8 and 9, we have a score of 3 because both of the 8th and the 9th score is 3. So that means Q2 equals 3. So what we see is that Q2 minus Q1 equals 3 minus 1, which is equal to 2. And Q1 minus 0, Q1 minus 0 is equal to 1 because it's 1 minus 0. And so we see that this is double that, and that is in line with what we observed there. So A is good because we're trying to identify which of these histograms is not possible. Next, here we have our min, which is equal to 0, okay? And that's our first score that we saw here. Then our second, third, fourth, and fifth. Our fourth and fifth score is 1, so what's in between that? 1. And our median, our Q2, is between our 8th and 9th, so this is 6th, 7th, 8th, 9th. 8th and 9th score both have a score of 3. That's equal to 3. Yet again, this is identical to A, where our Q2, Q1, and minimum are the exact same, so B is correct. Here, I'm just going to write this again. What we have is our minimum is equal to 0, which is our first score. Then we have our second, third, fourth, fifth. Fourth and fifth both have a score of 1, so Q1 equals 1. 6th, 7th, 8th, 9th. What we see is that the 8th score is a 2, the 9th score is a 4. So our Q2 falls in the middle of 2 and 4, which actually ends up being 3. What we see is, yet again, this is identical to the others, where Q2 minus Q1 is double that of Q1 minus the minimum, so C is good. By the process of elimination, that then means D is the odd one out, but let's kind of do D for the sake of it. 0, 1, 2, 3, 4, 5, 6. Our minimum is 1, which is the first score, so min equals, is 0. The Q1 is between our fourth and fifth score, so this is our second, third, fourth, fifth. 4 and 5 have a midpoint of 2, so Q1 is equal to 2. 6, 7, 8, 9. So our Q2 falls between the 8th and the 9th score, which is equal to 3, as the 8th and 9th score both have a score of 3. And what we can see here is Q2 minus Q1 equals 3 minus 2, which equals 1. Q1 minus the min equals 1 minus 0, which is equal to 1. This is not double to that, so that means D is not possible for the given box plot. Next question. Bag contains 2 red and 3 white marbles. Jovan randomly selects 2 marbles at the same time from this bag. The probability tree diagram shows the probabilities for each of the outcomes. So what we see is this tree diagram. Given that one of the marbles that Jovan has selected is red, what is the probability that the other marble that he has selected is also red? So this is a conditional probability question. And what we see is we are being asked the probability that given one of the marbles is red, so there's at least a red, what is the probability that both of them were red? And using our knowledge from conditional probability, using Bayes' theorem, we know that the probability of A given B is equal to the probability of B given A times the probability of A over the probability of B. So when we translate it to our example here, what we see is that this is equal to the probability that we have at least one red marble, given we pick both red marbles, times the probability that we pick two red marbles, over the probability that at least one of the marbles is red. When we break this down term by term and determine what each one of them means, what we see is that it's equal to, what we see is that the first term, that the probability that that more than one of the marbles is red, given both of them are red, is actually just 1, because we're guaranteed that at least one of the marbles is red when both of them are red, times the probability that both marbles are red. And the probability that at least one of the marbles is red is exactly equal to 1 minus the probability that none of them are red. So as a matter of fact, 1 minus the probability that both are white. So what we get is something like this, where the probability of R and R, so a red marble is pulled on both tries, over 1 minus the probability WW, which means a white is pulled on both tries. Probability that a red is pulled on both tries is 2 on 5 times 1 in 4. If we just sort of follow this path here, that's what we get there. And that's over 1 minus the probability of white and white, which is 3 on 5 times 2 and 4. And that follows this path there. And just plug this in the calculator, calculate however you want it. You eventually get this to be equal to 1 over 7, which is equal to B. Final question, question 10. The diagram shows the graph y equals f of x, and it gives you a diagram. The point Q is a horizontal point of inflection. Let a of x equal to the integral of f of t dt. How many points of inflection does the graph y equals a of x have? Okay. So what it's saying here is that we have f of x, and if we integrate this, like if we take the integral function of this, we will arrive at a of x. So a of x equals the integral 0x f t dt. What we need to understand is, well, if we actually derive both of these and take the derivative, we get a dash of x, okay, because that's just the derivative of a of x. And if we take the derivative of the integral of this function, we just get the function. Okay, so we get what we observe is that the gradient function is this function that we have here. Okay, so what that actually means, why that is so significant, is because this graph is describing the rate of change of a of x. Okay, this graph here describes the rate of change of a of x. It's describing the gradient and how a of x actually behaves. So what that means is when our y values on this gradient function are positive, as they are here, that means the gradient of a of x is positive. When the y values are negative, it means the gradient of a of x is negative. And when y is equal to 0, that means our gradient is equal to 0, so there are stationary points involved. So what does this actually look like? I'm going to do this in red. It doesn't matter where you translate this graph, up or down. It really doesn't, okay? The graph could, let's just say the graph looks like this, okay? Doesn't matter if we draw it like that or draw it like this, okay? Or if we draw it down here, like this. As far as we're concerned, when we're determining the points of inflection, they're all the same. So, like I said, we don't care about how high or how low this graph is drawn. All we care about is how it is moving. So in this initial part here, we have a positive gradient. and then we hit a stationary point here because the y value is 0. Okay, so I'm going to have a positive gradient and y is equal to 0 on our original function, which means we have a stationary point. After that, we observe that we have a negative gradient up until our Q point here. Okay, this means that we're going to now be moving down until we encounter a stationary point at Q. Okay, stationary point here at Q. After that, we then have a positive gradient because we're above the y-axis, which means we're going to be moving up again. And we're going to come at another stationary point at where I've circled. So what that looks like is something like this. Okay, we have a stationary point that lines up there. What we then see is that we have another stationary point down here while we're moving down on a negative gradient as our y graph is negative. So it looks something like that. And then finally, we move into a positive direction where we have a positive gradient. So our graph would look something like this. Now, our points of inflection will occur between the stationary points. So there will be a point of inflection here, let's say, as there's a stationary point there and there, so it's somewhere in between. There's a stationary point here and here, so there's another one there, and there's a stationary point there and there, so there is another point of inflection in between those. I count 3 crosses. That means there's 3 points of inflection, and our answer is B.